Hello. All right. So today we're going to be taking a look at heat. So I think, I figured out what was going on last time and why you couldn't see the Google Doc that I was working on. So hopefully I solved this problem. Let me know if not. It'll be an adventure. Okay, here we go. So we're taking a look at page, I believe this is just 5, if I'm not mistaken. Nope, I was wrong. It is page 6. All right, so what you're going to do is follow along, and I'm going to apologize in advance because I'm quite positive that as I fill in the blanks, it's probably going to go all wonky. So have fun with that. I'm sorry, unfortunately, I don't have a PowerPoint to show you for this one, and so you'll have to, I have a couple videos to show you, and then I also yeah, we'll go through with the Google Doc. So hopefully that'll work out for this lesson. We shall see. It'll be an adventure. Okay, so first of all, heat, that is the amount of thermal energy transferred. And we're going to get more into that in a moment, so it's okay if you're still kind of wondering. It must have a temperature difference between the bodies. Heat moves from an area of higher energy to lower energy. Energy movement will stop when both bodies in contact, oopsies, have the same, ooh, I'm on a roll, have the same temperature. So we're looking at this picture here, and we see that we have some insulated containers, and they have it where they have this metal strip going in there in between. And what will happen is, what's really neat is, if over here, oh, unfortunately in my notes it has the degrees written in there. It's probably hard to see this. So this container right here, the one on the left, that one is 30 degrees. This one right here on the right, that one is 10 degrees. And so what's interesting is that we're going to see that there's going to be heat transferred from this container over to this side here until they're both the same. So actually, if you haven't done the math already, I'd be curious to see if you've done it. But what will end up happening is the final result, the final temperature, it's going to be the average between the two, which would be 20 degrees. Both containers of water should end up having it where they have a temperature of 20 degrees after the heat has been transferred. Okay, now we're going to take a look at a few different methods of heat transfer. And so what I've done is I have, first of all, a few videos for you to look at. They're short. And so we have one on conduction, and then we have another one on convection, and then have another one that has to do with heat radiation. So first, let's just take a look here. So looking at the definition here, that it says conduction is the transfer of kinetic energy between neighboring molecules or atoms due to collisions. The hotter molecules lose some of their energy to cooler molecules and so pass it along. So metals are really good for conducting heat. Convection, think of like a convection oven or something like that. That's the transfer of kinetic energy through the movement of molecules or atoms from one place to another due to changes in density. So what happens is the heat rises, the cool air goes down, but if the heating source is at the bottom, then what happens is, as that cooler air is going down to the bottom there, it gets warmed up and that goes up higher. And so it basically makes it so that everything is an even temperature. And if you take a look at this picture over here, we see just the very basic premise of a convection heating element. We have heat here, and then liquids and gases are great for being able to have heat transfer through convection. And so we have the heating element here, the heat rises, the cool air up here gets pushed down, and then it gets in contact with that heating element and it starts to warm up and goes up. And so it's like this continuing cycle. It's a nice even temperature. So that's why if you have any of your parents who have a convection oven, I have a feeling that they probably got excited when they got it, because like, yes, it's going to cook food better. because what happens is in a convection oven, it has heat, has hot air that is being blown continuously, so that way throughout the oven, so that way everything stays at the same temperature and not just certain elements that are in closer contact with the heating element than others. All right, so we also have it where with radiation, the transfer of energy via electromagnetic waves, and that travels at the speed of light. And this video over here, kind of cool, it talks about how that works, especially how obviously the sun is a source of radiation. And what types of materials and surfaces will end up either reflecting or absorbing that heat better. And so you can think about maybe different types of clothing you've worn out on a really sunny day, what has been making you feel a lot warmer, which have kept you fairly cool. Think about that as you are watching this video. All right, so what I'll do is I am going to finish this part here, and then I will go on to, I'll stop this video and go on to the next one, or the rest of the pages in the next video. So using the kinetic molecular theory, explain why does the temperature near the ceiling of an enclosed room, why is the temperature higher than near the floor? So if you were to, and this will be on your Google form homework check, just a heads up. So using the kinetic molecular theory, we know that with convection, that cold air, which is heated at floor level, becomes less dense and rises. Oh, fantastic. You can't read all of that. Let's see if I can make this work. There we go. Oh, technology, gotta love it. Okay, so yes, the cold air that's heated at floor level becomes less dense and it rises. Okay, you've probably also heard of the phrase that warm air will rise. So that way, if you, let's say, in a cabin and you're on the top bunk bed, greater chances are that you might be a little warmer on the top bunk compared to the lower bunk. All right, let's have it where we'll come back for part 2.